continue on, how does the graph of g of x equals quantity x minus 3 squared minus 4 different from the parent function? All right, I don't know. Let's let the calculator do it. We have the parent listed first. It'll fly in first over here. If your window is all messed up, make sure you do a zoom 6. That's a standard viewing window. And here we go. There's the parent. And there is the offspring. So on that one right there, what we did is we translated 3 to the right and 4 down. 3 to the right and 4 down. And if you notice right here, look at the vertex. Put your pencil on the vertex and count over 1, 2, 3. And then go down 1, 2, 3, 4. And you're at the other vertex, or low point to low point. So just focus on that, and that'll tell you how it translates. So as we look at the next problem, how does that one, coefficient, remember coefficient is a number in front of the variable. So what we're going to do here on that one is we're going to put the parent there, change the coefficient, the number in front to 3/5. I'm going to press graph and we're going to look. There's the parent and there's the offspring. It is wider. So on problem number 12, using our calculator, the translation, it is wider. Number 13, as we take a look at that one, same thing, describe the effects, put them in your calculator, you'll have this right here. Again, the parent and the offspring. We press graph. Oops, see, we've got a bad screen, so what you need to do is press zoom. Once this thing stops, see how we're only getting part of the curve? Do a zoom 6, and it'll go back to normal. Standard viewing window. Alright, so what happened here? Well, it looks like it got reflected over the x-axis because it's now opening downwards. It got translated to the left 1. Again, we're looking at the vertex. We go left 1 and then we'll go up 9. So it was reflected over the x-axis and it was translated 1 to the left and 9 up. Number 14, a direct variation problem. Anytime you have a direct variation, the variables are proportional. So as we take a look at this, we have a 46-inch, a 46-pound weight, stretches the spring 4.6 inches. And so how many pounds does it take to stretch 10 inches? And what we'll do is we'll cross multiply. We'll multiply that way and get 4.6x. We'll multiply the other way and get 460. Divide both sides by 4.6. And you use your calculator to get an answer of 100. Number 15. We are given this problem. We're given 2 ordered pairs and the slope, and we want to know what is this missing coordinate. Well, we got to go back to our slope formula here. We got to subtract y's and x's. So I'm going to just make this a 1 ordered pair. It doesn't matter which one is which, but I'm going to make this one first so my variable comes first. And I'm going to subtract y2 minus y1. So that's going to give me w minus a negative 6. And then I'm going to subtract the x's in the same order. 3 minus a negative 12. Well, what that does over here, remember double signs, that's addition. Double signs is addition, so it cleans up to this fraction. Okay, 3 plus 12 is 15. So now this has to be true because this is slope right here, and this is also slope of the same line. So what I want you to do now is I want you to get a common denominator. The common denominator is 15. Remember from elementary school? 1/3 is 5/15. So if I change 1/3 to 5/15, once we have a common denominator, all we have to do is look at the numerator. What number plus 6 is equal to 5? So we do w plus 6 equals 5. How do we solve that? We subtract 6 from both sides, and we get w is equal to a negative 1. 5 minus 6 is negative 1. So w is equal to negative 1. So as we take a look at this right here, the next one, during a recent flight, hot air balloon, what is the rate of change? How is my inputs or my x's changing? They're changing by 0.5. How are my outputs or the height changing? It's going down, so I'll say negative 500, and I do a delta y over delta x. Negative 500 divided by 0.5 is going to be a negative 1,000, and we're talking about feet per hour. Okay. Number 17 is the same thing, the rate of change. So we're looking up here, this delta x is going up by 20. This one is going down by what, 125? And so what we'll do is the same thing as we did on the previous. We'll do a delta y over a delta x. Take out your calculator, and it's going to be a negative 6.25 meters per second. All right, arithmetic sequence. Okay. Now, we did it one way. We talked about taking the arithmetic sequence and saying this number is stage 1, this one is stage 2, and so on and so forth. And we had a formula on a chart. We said in the starting amount plus, because it's arithmetic, n minus 1 times the common difference. So we could do it that way right here. We can do starting amount is 2. We can do this as well. Common difference is 11. 2 plus 11 is 13. 13 plus 11 is 24, and so on. Distribute to get 11n minus 11. Combine these right here, and you have your example. Now, here's a little challenge for you. What I want you to do is, if you want to, come back up here and use a linear regression. This is y equals mx plus b, so it's linear. So go back in your calculator, enter L1, put 1, 2, 3, 4, 5, and in L2, put 2, 13, 24, 35, and 46, and do a linear regression and tell me what you get. It'll put a smile on your face. All right, the last ones are dealing with writing equations. We got our 3 forms, our point slope, slope intercept, and standard form. And in all these problems, you need a slope. So we're going to do a delta y over delta x. In this particular problem, my slope is going to be negative 2/5. Remember double signs, that's addition. 1 plus 3 is 4. So, point slope form, it's a great place to start. Pick either one of your ordered pairs. I chose the first one, you could choose the second one. Put your y value here, put your slope that we just found in the middle, and put your x value here. If you have any double signs, go ahead and clean it up. And when you clean it up, guess what you have? You have point slope form. Now, use this to go to the next form. Distribute your negative 2/5, you get this, and isolate the y. In this case, I'm going to add 1 to both sides. Use your calculator if you need to. And guess what you have now? You have y equals mx plus b. You have slope-intercept form. And then finally, take that, multiply everything by 5 to get rid of the denominator here. So I'm going to distribute a 5, and that's going to give me 5y equals negative 2x plus 7. Standard form, all I got to do is move this x over here to the left. I do that with a 0 pair. I'm going to add 2x to both sides, and guess what I have? Standard form, ax plus by equals c. So on problem number 20, it's essentially the same thing, but we bring in the parallel and perpendicular thing. So looking at the picture, you can verify this. I have a slope of negative 2/3. I want to go through point 6, negative 2. So I have a point and a slope. Oh, guess what I'm going to do? With the parallel lines, you use the same slope. So you have a point in the slope, so point slope form. Here we go. Plug in your information. Clean up any double signs before you begin. Guess what we have? Point slope form. Now, continue with that. Distribute. And move this 2 to the other side by making a 0 pair. Guess what you have? Slope-intercept form. And now I'm going to multiply everything by 3 to get rid of my fraction. So I get 3y equals negative 2x plus 6. And all I have to do is move this to the left with addition. And I have standard form. Now, to be perpendicular, I'm going to use, I got to give it the old 1-2 punch, right? Remember what that is? I got to use the opposite reciprocal. So I'm going to change a negative to a positive, and I'm going to flip 2/3 to 3/2, and I'm going to do the same thing. I'm going to now use this slope because I'm perpendicular, and I'm going to go through the same point. Process is going to be the same. It's a great place to start. Clean up your double signs. What form do you have? Point, slope. Distribute. Here and here. Subtract 2. What do you have? Slope-intercept form. And finally, we're going to multiply everything by 2 to get rid of the fraction. And that's what I did was I switched sides here, in case you didn't catch that. I just switched sides so that the x would already be there. You don't have to. I still multiply everything by 2. Okay, and now I need to move the y over here, and I need to move the x, minus 22 to the other side. So I'll move my 22 with addition, and now I'll move my 2y with subtraction, and there we go.